Welcome into my video on Introduction to Mole Conversions. In this video, I'm going to define what a mole is and some of the basic conversions that we do with moles, and connect it to the previous video on dimensional analysis, because really we're just going to be applying the dimensional analysis skills that we talked about in the previous video to what we call moles. So the question here that we're going to go through is how many hydrogen atoms are in 25.0 grams of H2O. Okay, so this seems to be some sort of a conversion. We're converting from grams to atoms. Now it turns out there's no direct conversion for that. Okay, the connector is what we call moles. Okay, now really the definition of a mole is this number, 6.022 times 10 to the 23rd, or Avogadro's number, of particles. That's what a mole is, in the same way that the definition of a dozen is 12 of something. A dozen bagels is 12 bagels. 1 mole of, say, hydrogen is this many hydrogen atoms. Okay, now the particles, this can be a little bit tricky. Sometimes the particles are atoms themselves. Sometimes they're molecules or formula units. Kind of depends on what our substance is. So here our substance is water, H2O. This is not just like an individual element. This is a covalent compound. So the individual particles of a covalent compound are called molecules. Okay, so 1 mole of water is this many water H2O molecules. We'll see how that plays in. And then we can also convert moles to grams or vice versa using what we call the molar mass, which comes from the periodic table. So this is the decimal number on the periodic table, usually written on the bottom. It's also called the atomic mass, but in this context, we're going to be calling it the molar mass. And it tells you how many grams are in 1 mole of that substance. And so in the case of H2O, if we look at the periodic table, hydrogen's got a molar mass of 1.008. We're going to have to multiply that by 2 because there's 2 hydrogens. Oxygen has a molar mass of 16. And so if you add that all up, for water, this number is going to be 18.016 for water. That tells us how many grams of water are in 1 mole of water. That's what molar mass means. Okay? How many grams of that substance are in 1 mole of that substance. And that's going to be different for every substance. We get that from the periodic table. And then again, what this means in this context is that 1 mole of water is this number, Avogadro's number, of water particles. Well, again, we mentioned that the particles of water are called molecules, because water is a covalent compound, and that's just the name of the individual particles of a covalent compound are called molecules. Okay, so we're going to use those conversion factors to help us with this. Okay, so we're going to start with actually the amount given at the beginning of the problem, so 25.0 grams of water. And if you remember, the starting number usually does not have anything in the denominator, but if you want to, you can just write that over 1 just to clarify that that's in our numerator. And then if you remember from the previous video on dimensional analysis, whatever unit is on the top, you typically want to put that unit on the bottom in the next step to cancel it out. So we're going to want to put grams of water on the bottom. And then if we look here, what can we convert grams to? Well, we can convert it to moles using the molar mass. So I'm going to put moles of water on top, and the conversion there is 18.0 18.016 grams is 1 mole, okay? So in this case, the molar mass goes on the bottom, so we'll be dividing by it. Now, sometimes the molar mass goes on top, depending on how you're doing the conversion. And so sometimes students get confused about, do I multiply or divide by the molar mass? There's a few ways to think about this, but the easiest way for me, again, is just line up the dimensional analysis, line up the units properly using dimensional analysis. So if we have grams on top, we need to put grams on the bottom like this. And then the molar mass, the number, will always just go wherever the grams are. So in this case, since grams is on the bottom, we put 18.016 on the bottom. If we had started with moles, if we were converting, instead of grams to moles, we were converting moles to grams, if you can imagine that, moles of water, and we wanted to convert that to grams, well then we would be putting moles on the bottom to cancel that, and grams on top. And once again, the molar mass is always just going to go wherever the grams are because it's the number of grams in 1 mole. So in that case, it would go on the top. Okay, so this is a situation where we'd be multiplying by as opposed to dividing. But again, if you just are kind of fluent with dimensional analysis, you don't really have to like memorize that. So do the grams to moles first. Grams cancel. And then now we know this conversion as well. So we have moles now on top, so we're going to put moles on the bottom. We know how to convert that to molecules of water. And again, just put the corresponding numbers with the corresponding units. So 1 mole of water is 6.022 times 10 to the 23rd. So the moles cancel. Now, in a lot of problems like this, you would be done at this point. However, here we're not quite done because again, we are looking for the hydrogen atoms, which is a type of particle, but it's not the particle that we got here. Because again, the particle that you're going to get is the, because we had moles of H2O, so we're going to get how many H2O particles we have, which are called molecules. That is not the same thing as how many hydrogen atoms. So now we would like to be able, if possible, to put molecules of H2O on the bottom to cancel that, and then atoms of hydrogen on top, because that's what we're trying to find. So if there's a direct conversion from here to here, that's what we would like. Well, it turns out there is, because, I mean, a water molecule just looks like this. So this whole thing, that whole thing is the molecule. These individual, those are your atoms. And even this is an atom. It's just not a hydrogen atom, it's an oxygen atom. So what this tells us, if we just look at this, is in this 1 molecule of water, I guess I'll just singularize that, because there's just 1. In 1 molecule of water, there are 2 atoms of hydrogen. That's our conversion for that. And now we're into atoms of hydrogen, our desired unit. So let's go ahead and do this calculation. Remember, you can ignore any 1s. The other numbers you're going to multiply along the top, divide along the bottom. So we have 25 times Avogadro's number times 2, and then divided by 18.016. And we're going to keep 3 significant figures because that was how many were in the starting number. So that's going to give us 1.67 times 10 to the 24th atoms of hydrogen.